Greetings friends, welcome to NMartech. I am Engineer Martin. Let us learn electromagnetism and mutual inductance with its application to AC welding machines. Electromagnetism is a concept that treats two complementary and important terms in electrical engineering: electricity and magnetism. They go hand in hand, as magnetism is used to produce electricity while electricity is used to produce magnetism. When a current is passed through single wire, there is magnetic field around that wire. If the current source is put off, the magnetic flux around this wire collapses into the conductor and induces electric voltage in the conductor even as the original current source has been put off. The generated magnetic field and the induced voltage here is usually very little because it is just a single length of wire. In order to produce larger amounts of magnetic field, we need to roll the wire into a coil of a given number of turns. This will also result in more value of voltage induction into the wire when the original voltage source is put off, or into another wire placed in the magnetic field produced by this original voltage source. This concept of electricity producing magnetic field and then magnetic field producing induced voltage in a particular system is known as mutual inductance. This coil of wire can be wound around a core for transformers, or inside laminated slots for motors and generators. When current is passed into an arrangement of coils, magnetism is produced with flux direction corresponding to the arrangement of the coils and direction of flow of current. When a coil is made to rotate within a set magnetic field, or a magnetic field is made to rotate within the axis of a coil arranged in slots of a stator, electricity is produced, voltage is induced in the coil. This rotation is to enable this coil cut the magnetic field at an angle, 90 degrees. At this angle, maximum voltage is induced in the coil. This expression is the principle of AC generator construction. When a current-carrying conductor is wound and arranged inside slots, magnetic field is generated within its stator, thereby making the stator an electromagnet. An electromagnet is an electrically produced magnet. They are most efficient and most used for electromagnetic induction. Electromagnets are used in generators and electric motors construction rather than the permanent magnets like the bar and horseshoe magnets. When current-carry conductor is wound around a core and another coil is wound around the same core, there will be an induced voltage across the second coil. This induced voltage arises due to magnetic flux from the current-carrying coil into the core. This flux gets in contact with the second coil and causes production of electricity in the coil. By manipulating the number of turns, you can determine the amount of voltage or current that will be achieved on this second coil. This principle is utilized by transformers and AC welding machines. Our major focus is on its application to transformers and welding machines. AC welding machines or welding transformers are basically step-down transformers. They have more turns on the primary windings than on the secondary windings. This means that there is more voltage and less current in the primary windings while the opposite occurs at the secondary windings. The high current achieved in the secondary windings is used to melt electrodes for welding when connected in series with a load. Join our online welding machine training class to see all these yourself. It is a very interesting class to partake. To join the class, call Engineer Martin at +234 81460699849. Or send an email to nmartechelectrical001@gmail.com. Remember to click the subscribe button to subscribe to our channel, and like the video in order to get notified of new posts. Thank you.